All right, so let's go ahead and make an intake. I should have in the assignment linked this document. This document has a chassis already done, and I've put all those things into a folder. And so if you click the Home tab, you'll see all your chassis things are in a folder. So the first thing I want to do before I get into making my intake is I want to create a full bot assembly. We're going to do this so that we can have in-context editing, which you'll see what that is later. What I'm going to do is I'm going to click this plus icon. I'm back at the Home folder. I've clicked Home. I'm going to click plus and create an assembly. I'm going to rename this assembly full bot. Okay. Let's go back into the chassis folder. Let's see what we've got. We've got Part Studio 1, which let me actually rename that as Chassis Part Studio. And Assembly 1, which I'm going to rename as Chassis. All right, let's go back to the Home, and we'll find the full bot assembly, which shouldn't have anything in it yet. I'm going to click Insert, and I'm looking in the current document. I'm going to look at my assemblies, and you'll see the only assembly I have so far in this whole document is the chassis assembly. Let's add that to the full bot. Now, one of the reasons I made this reference cube is so that all of my assemblies can kind of be positioned relative to each other. So I do want to click Fastened, and I want to fasten the top of this cube to the origin pointing up. Okay, there we go. I also don't like seeing all these mate connectors. Let's hide all mate connectors. There we go. So I fastened that in place, and none of it should be able to move at all. If you did the chassis assignment before, you'll notice there's some small differences. I've added some bumper mounts. I've took out this section of the bumper, which these days FRC makes you have full bumpers, but back when Artemis was made, we had a gap here so that the ball could come in, and that was legal then. So just use the one I've got here, even if you made your own chassis. Use this one because it's updated. I've also made sure to add bearing holes here to the chassis where we're going to mount our intake. So it's already there. All right. So the next thing I'm going to want to do is start making my intake. So I'm going to go click, make a new folder, create folder. Let's call this folder Intake. And within that intake folder, I'm going to create a new Part Studio. And they call it Part Studio 1. Let's call this Intake Part Studio. Okay. I'm going to make a reference cube, and then I'm going to make an intake assembly. So let's sketch a reference cube here in the top plane. Center point rectangle. It's 1 inch by 1 inch. And I'm going to extrude it downwards. Okay. Let's go ahead and create an intake assembly. So let's click plus, create assembly. It's called Assembly 1, but let's rename it as Intake. Let's go ahead and insert our reference cube. So we're looking in the Intake Part Studio. We're selecting Part 1, which is the reference cube. There we go. And just like we always do, we're going to fasten this reference cube to the origin. So let's click Fastened. There we go. All right. What do we do now? Well, we could start modeling intake parts, but I want to take advantage of what's called in-context editing. So the first thing I'm going to do is take my intake assembly, which right now is only the reference cube, and place it into my full bot assembly. So let's go back to the Home. Let's find my full bot assembly. Here we are. And let's insert. We have our chassis in here. Let's insert the intake. Insert. Let's look under Assemblies. There's my intake assembly. So I'm going to click it. And you'll see all I have is a reference cube. But I'm going to make sure that that reference cube is fastened to the same location as my other reference cube. Now that it is, and it's in here, I'm going to do what's called in-context editing. I'm going to edit my intake parts with a ghost of the rest of the robot around. Before I do that, let's hide some things that I won't need. So for instance, I won't need the bumpers when I'm making this, and I won't need the bumper mounts for sure. Okay. I'm hitting the Y key as I hover over things. That's a great way to hide things quickly. I probably don't need the swerve modules as well. They're going to kind of be in the way. I'm really going to need this rail here, and I might want to be away where the front and the back rails, and maybe the belly pan here. So let me hide these side rails here. So this is kind of what I'd like to be able to see as I reference and build my intake. So this is what the context I want to build my intake in. All right, so let's go into my intake parts, and we'll find part 1. This is the reference cube. And you can do this for any part that's in the assembly, but this is the only part from our intake. So I'm going to right-click on part 1, and I'm going to select Edit in Context. What that does is it takes me back to my intake part studio. You can see at the bottom I'm in my intake part studio, but it now shows a ghost of the full bot assembly in the state that I had it in. This is really helpful because I'm going to use this to build things. So for example, well, actually, I'm not quite done. I've got my context here. I also need to import or derive my intake 2D sketch. So I haven't done that yet. There's a lot of setup that goes into these things sometimes. Let's find the derive tool. And if you can't find it, you can always use search, but it looks like it's under this menu here, derived. I'm going to select from other documents. This is in the FRC team drive under shared CAD, Artemis practice CAD, 2D sketch. And let's go ahead and let's put in, we really just need the intake sketch, I believe. It might be useful to have the chassis side view later. I don't think we need it. Yeah, I think we're good. I'm just going to use this. All right. So now I've got this sketch built in here too. So I've got my derived sketch, my intake. I've got my context open. Let's kind of start building. I think the first thing I'm going to want to do is start building a plate. All right, let's build a plate, a side plate. So where am I going to build that plate? Well, it needs to be sort of offset a little distance away from this side rail, enough where I have space for this bearing. I actually also want to have space for, there's going to be an intake, the indexer structure here that's going to attach to this rail on the outside about 1/4 inch. So maybe it needs to be a 1/2 inch off of that. Let's go ahead and do that. Let's click plane. Let's grab my plane tool. I think it's under the derive now. Yep, there's the plane. Find your plane tool. I'm going to select this plane right here to offset off of it. And I'm going to offset from there. It's an offset plane. Let's do 1/2 inch. And I'll be able to change this later if I change my mind. There we go. So this is the plane I'm going to create my intake side plate in. Let's click sketch and let's select that plane. Oh, one thing worth noting. Do you see how plane 1 here has got this yellow arrow? That means it used the context. This is important because you want to know what context you're using to design these things. And also, if you never use the context, it will disappear. But now that I've used it, I can go up here and I can select the context 1, or I can turn off the context. But because I've used it here, I can go back to it, and then we can see all the things that have been made out of that context. All right, let's reopen Sketch 2. All right, so what's this plate going to do? Well, this plate needs to be the pivot point here on the chassis. It's going to connect via a belt here to power the intake. And something not pictured here is it's going to connect via chain right here as well. That's going to allow me to pivot the whole intake. All right. And then from the power of this motor, it's going to belt up to here and down to here to get these wheels spinning as well. All right. So the first thing I might do is to take any geometry from my sketch and insert it in. So for instance, I need to know where this wheel is and where this wheel is. That way I get the distance between them correct. I definitely need to know the center right here. And I think that's all I really need right now. Let me go ahead and hide the rest of that sketch. All right. So what's this plate going to have here? It's going to have a hub, inside of it, which I believe the diameter of that hub is the same as the diameter of the bearing. Let's do 1.125. I might be wrong about that, but I think it is. So it's going to fit a hub inside of it. And then on the outside, it'll have to have some holes to attach to the hub. But I might wait until we put a hub in it before I'll use those holes to put the holes in here. Actually, let's not. Let's just look up what that whole pattern is. Let's go to ThriftyBot. I'm going to use, they have a lightweight hub that I like. Is it under motion? I know, I'm just going to search for hub. Number 10 hole pattern hex hubs. Here we go. And we've got the 1/2-inch hex bore thin hub. I'm going to use the thin hub. They include both a 1.875 and a 2-inch bolt holes pattern. So we can use either one. Yeah, let's go with the thin one. Let's go with the 2-inch bolt pattern. I always like that. And it looks like they are spread out in 1, 2, 3, 4, 5, 6 holes. While I'm at it, let me go ahead and download this CAD file. It's right here. Hex hub 0.375. Which one are these? Let's get a list here. Thick. Here's the thin one. I'm going to download this one. Okay, so I've got it. Let's go back to our document here. So it's got a pattern here of number 10 holes, 6 of them on a 2-inch bolt circle. Actually, let's not do that. Let's grab the bolt circle. 2-inch bolt circle. I made that a construction line because it's not actually a feature. It's just, I'm going to use it to build stuff off of. 0.201. And let's grab my circular pattern tool. Pattern that with its center being right there. And there's going to be 6 of them. Okay, so I've got that. Let's go ahead and do the rest of this. Let's see here. Up at this point, there's going to be another bearing. 1.125. 1.125. This is our standard bearing size. We can make it 1.126, but this is polycarb. We can usually shove those in pretty well, or we can grab the reamer if it's too small. Grab the line tool. I'm going to create a line that goes from here up to here. If I take the line tool back on itself, I can now make a curve. I like that. That's a nice little convenient thing here. Be careful. I don't want to see how it makes that orange line. That's going to force that to be horizontal. I don't want to force that yet. So I can either avoid it and click, or I can hold shift. And I'm trying to avoid accidentally having constraints that I don't want. There we go. Let's add some of our constraints. Coincidence, a big one. Any of these arcs, I want them to be coincident and centered around the feature they're going around. So for example, this one right here, I want it to be that right there. And this one goes right here. Okay. Let's define some dimensions of these here. Let's make this maybe 1 inch. Let's see if this one works with 1 inch radius. Okay. This one, let's make this a bigger radius. Let's do 2 inches there. And this one here's going to be a larger radius as well. Let's try 2 inch. That's too big. 1.5. Okay. That might even be too big. Let's do 1.25. I think that works. Cool. You can see a lot of these things are still blue, so they're missing some constraints. I think we're missing a lot of tangents. For instance, this is clearly not tangent to that. While we're here, let's make sure this one is. Let's go up here. This one and that one. Essentially, these features should go black if they're fully constrained. I don't think I've got the location of this here constrained. I think what I'll do for this one is I'll say that these two sides have to be parallel. There, and then this one has to be parallel to that as well. Okay, it looks like maybe I'm still missing a tangent here. If you ever don't know what constraint you're missing, let me undo that one. So let's say I didn't know what constraint I'm missing here. If I don't have any tools selected, I can grab one of the blue dots and I can usually move it. See, like I'm moving it. So now it becomes obvious what I'm missing. I'm missing that this being a smooth transition. So if you ever don't know which constraint you're missing, try to make it obvious which one you're missing. Okay. I think that's good. Okay. This looks like a decent plate. I think the only thing I might be missing is as this pivots in and out, there's going to be an indexer in the way here, so I can't run anything between the two side plates. But up here, I might want to have some structure as this belting and these wheels are here, something to keep this distance right. So let me go ahead and add that. Now, if I bring the other sketch back, you can see that my intention on this is to have, I believe, 2.25 inch wheels. Let me move this up here, 2.25 inch wheels. So those are there. So I want to make sure, and this is why this sketch is helpful, that if I'm going to put a churro here, I need enough distance between it and the wheel. Let's go 1/2 inch distance. That way I'm not going to accidentally, have my churro hitting it. And actually that needs to be not a construction line. There we go. So this distance here, let's make it 0.5. Oops, undo. 0.5. Now, if these are churro, they take a 1/4 bolt in the end. So let's just go ahead and dimension these holes to be 1/4 inch. And we'll make them both equal. Just like that. Cool. I think that's pretty good. I may have more things to add later, but essentially that's it. I'm going to click the green check mark. I'm going to select that area, and I'm going to extrude it out. This is going to be made of polycarb, 1/4 inch polycarb. So let's make it 1/4 inch thick. Let's also right-click the part, edit the appearance, add a little bit of transparency to kind of convey that it's polycarb. It's kind of a smoked polycarb there. There we go. Cool. So that's that. Well, what do we need next? Next, we're going to need, let's add that hub in. Okay, let's put that hub in here. So I downloaded it from the ThriftyBot website. Let's click plus and import. And let's go to my recent files. There it is, the hex hub. And I'm going to combine it into a single part studio. It's a nice simple part. We should be able to see it pretty easily. That way it's not a complicated thing. Oh, here it is, it popped up. There it is. So I've got this part now. Let's go back to here and let's derive it in. So let's find my deriver, derived, and let's select from the current document. Here it is. There it is now. And let's go ahead and transform it. Transform. I'm going to transform this thing by mate connectors. From mate connector, I'm going to take this part right here. I'm going to have it fit right in this hole right here. See how well my holes align. They look to be spot on. That's perfect. If not, I might have to apply another transformation. One thing I didn't check is, it's not, I put it on the wrong way. Let's go back to transform and let's flip the primary axis. Okay, so that looks good. We're at the center of my hub right there. It does look like when I guessed the size of this piece here that it's correct. It fits right in there. They made they did a good job picking that to be bearing hole sized, and that fits right there. Cool. All right. What else do I need? Let's go ahead and mirror this to the other side. Okay. So the chassis is centered around the right plane here. I could also do a mid plane between these two sides if I wanted. But let's go ahead and just select mirror. And the entities to mirror, I'm going to mirror this. I'm also going to mirror my hub. And I'm going to mirror it across. Be careful mirroring a hub or a COTS part. Like if they don't have the mirror version of it, you won't be all right. This part, if you mirror it, it's identical, so you don't need to worry about that. But be careful mirroring a part. You don't want to turn it into something that doesn't exist. Okay, there we are. That's over there. That's looking good. Okay. Let's go ahead and connect my two sides. I was going to do some churro here. Now that I've got this, let's go to my tools. If you don't have the shaft generator yet, recommend it. Go look for this feature script, install it. Here's the shaft generator. I don't really like the way the shaft generator does this, but it has you select the type, which we're going to use churro. We're going to use the end face will be this surface here, and my origin is going to be the other hole over here. So there it is. You can see I've used this tool recently because I have some end offsets. It remembers your old settings, which some tools is appreciated and others it's not. So your offsets should be 0 there for this situation. I don't think I can select more than one origin. No, I can't. I've got to pick one. So I'm going to have to reuse the tool. Select this shaft generator. End face is over here. Origin is right here. And there's my other churro. That looks good. Cool. Let's go ahead and derive in some bearings. Let's do some Thunder Hex bearings. Use the 1.125 outer diameter. We use the flanged one. So let's click that. It should derive it here right into my reference cube. I'm going to hide my reference cube. It gets annoying trying to find things because they always derive on the origin. And now let's transform it. Let's transform this by a mate connector from that location to this location. Now, this is something that I might be tempted to put in the assembly, but I like putting them in here because, and let me copy the part because I have a few of them, because if I derive them in here, I can use them to determine my shaft lengths. Because you add that little flange there, and it will increase the length of your shafts. So having them in the part studio, that's pretty nice for that. Flip it. Let's copy the part. All right, we're transforming the next one. Oops, not that. I selected the wrong thing. I might want to hide the context. Let me cancel that. Let's get rid of this context. There we go. Now let's transform. Should be easier to select the stuff I want by mate connectors. From that mate connector to that mate connector. It needs to be flipped. And last one, let's copy it. We're going to transform this thing from this mate connector to that one there. Cool. All right. What to do next? Well, let's go ahead and add our front set of rollers here. So the first thing we'll need to do that is a shaft. It's going to be going through this front. I'm going to make this Thunder Hex. Actually, let's do the rounded hex. That's actually what we use. We don't use Thunder Hex because its center was tapped to quarter, and now we like it center that we can tap to number 10. So we'll do the rounded hex here. So we need to select an end face, which we can put that on the end of this flange. And then we need an origin, which will make it here, right here. There we go. Looks good. Looks awesome. And then we just put a washer and a bolt in the end there to retain that. So what goes on here? We've definitely got some wheels. So I think they're 2¼ inch. Yep, 2¼ inch compliant wheels. And then we also have, looks like a pulley here. If I click that, that diameter is 1.504. Whoever made the 2D sketch already did this work for us. Sometimes you have to do it as the designer of the subsystem. But sometimes it's done in the 2D sketch. 1.504. You might say, well, what size pulley is that? Let me go to WCP belt calculator. And I'm just going to look and find what 5mm pulley has that size. So 5 millimeters. This is the pitch diameter. I'm suspicious it's 24 tooth. Yep, we use a lot of 24 tooth because they come in aluminum. So if it turns out that we don't want to use a 3D printed one, we can switch it to a very sturdy aluminum one. So this is a number 24 tooth. Or sorry, not a number 24, a 24 tooth pulley. So let's go ahead and get a 24 tooth pulley in here. I'm going to use the MKCAD driver. I'm going to do HTD pulley. And I want to select my configurable ones. We've got a configurable crown pulley, custom configurable HTD pulley. I'm going to select that one. The specifics on this, talk to a mentor, talk to an experienced student about the dimensions you're looking for here. 5mm pitch, that's the size belts we use. 24 teeth, yep, that's what we want. The width, how wide is the belt? Well, we have 9mm and 18mm belts. I think we should use the wider, or 9mm and 15mm belts. I think we should use the wider one here because we're also going to put it in the middle to help guide the ball in, so we benefit from more surface there. Let's make this a 15mm belt, which means let's make it like maybe an 18. Let's do an 18.5mm wide. That way it's a little bit wider than the belt. It's got space for it. The bore is a hex bore. Diameter is a 1/2 inch hex, a little extra clearance there. It has a flange. It's a 1/16 inch thick. Let's make it a 2mm flange. I always think the flange should be a little bit bigger than the default here. And I'm going to not chamfer it. I think the belts stay better without a chamfer. Sometimes the chamfer helps it pop out. It does make them easier to print, though. And I'm going to get rid of the mate connectors. I don't necessarily like those. Actually, no, let's have them. I think this might be helpful here. All right, let's click insert. There it is. Okay. So let's go ahead and transform this thing and put it where we want. Transform. Let's grab the middle one. I think it's this one right here. There we go. Oh, I'm not transforming the mate connector. My mistake. Entity. Let's click the whole pulley. Now transfer my mate connectors. Let's select this one. We're going to send it to the center of this shaft. There we go. It's oriented correctly. That's pretty awesome. We need to put another one up here. So let's copy the part. And let's translate it. Transform it. I make connectors right here. Oh, I didn't do the other shaft yet. Dang it. Well, let's wait on that. Let's insert my other shaft. This shaft is going to end over here on this side. And its origin is going to be over here. There we are. Now, it is going to have to stick out farther because it's going to actually require a belt coming from down here up here to power the whole thing. Then we're going to have the other belt go in the middle. But so this needs to stick out. So we need to add an end offset. An inch, that might be good for now. I don't know if it will or won't be okay. I'm going to assume an inch is good enough. We always go back and change this. There we go. And now let's go ahead and get this transformed. This by mate connectors. Here's the center mate connector. We're centering it right on here. I'm using actually the 2D sketch to locate it, which works out fine here because it is centered. Oh, can I get it pointing out the right way though? Not sure if I can. There we go. Ah, no, it's not. Let's edit this. Let's rotate it 90 degrees. Instead of about Z, let's do about X. Oh, let's do about Y. There, that'll work. There it is. Okay, this isn't quite lined up there, so, but that's okay. I'm not going to worry about that today. I think I'm going to stop here. I don't want this video to get too long. I think that's a pretty good start, and I'll do a second video to kind of look at next steps where you can kind of get the idea of what we're doing here. We're using my 2D sketch to define some features. I've got my in-context editing going on here, so you can kind of make sure that it's fitting in line with stuff, and we can build off of, here we've got these right here. I can build off of that. So I've got lots of really good options for modeling relative to my other stuff. And I know it's going to fit because I'm basing it off of my 2D sketch. So I'm going to go ahead and stop the video here, and we'll pick up and do another one for the second half.